So in this video, I'm going to talk a little bit. This is I'm actually using question 15 from the homework 2 if for my 141 class. But this is in general talking about composite functions, and this question is particularly difficult, I think, because it you have to understand the table and understand composite functions to be able to work your way through this. So first of all, let's just talk about the table. Sometimes I think I have trouble reading tables. So the way this works is across the top is the labels, of course. So if you see here the X, this is the X column. So these are the X numbers you're plugging in for X, and F is a function, and G is a function. So this means when I plug in 1 into F, I get 1. When I plug 1 into G, I get 4. Likewise, when I plug 2 into F, I get 3. When I plug 2 into G, I get 2. So this right here, sorry. Okay. Let me get a different color here. These two numbers, 1 and 1, represent the point 1, 1 on the function f. Okay? So this is the input column. And these two are output columns. For different functions. Now, these last two columns are, they're asking you to do something. They're asking you to do a composite function. So this one says put the G inside of F, and this one says put F inside of G. So, so first of all, if we understand how composite functions work, we know that, we know that you plug the X into the inside function first, get a result, and then plug that into the outside function. And if you've watched my other videos, you've seen, so like this one, whoops, I lost my, this one is like this. I have the G function, and I'm dropping so for example, for this box, I'd be dropping a 1 in the G function, and then something comes out, and then it goes right into the F function. Okay, so let's work that out. So what happens when I plug a 1 into the F function? Well, or I'm sorry, a G function. This is G first, right? So when I drop a 1 into the G function, this tells me that a 4 comes out, doesn't it? Because this says 1 is the input, 4 is the output for G. So the 4 comes out and drops into the F function. So that means I need to go down to this column now, because the output of G becomes the input of F. So now 4 is the input, and I'm looking in the F column now because the 4 is dropping into the F function, and it looks like a 2 comes out. So there'd be a 2 there, so that means this is 2. Okay. Now this column is represented by, I drop in the F function first, something comes out, and it goes right into the G function. So in this case, if I'm dropping a 1 in the F function, according to the column, it says that a 1 comes out. So that means I'm dropping a 1 into the G function again. So again, this 1 is the input into the F function. This 1 is the output of the F function that we get right from here. So just to help you out a little bit, so here's the 1. That goes with that 1. And this 1 goes with that 1. Okay? So then, but then that green 1 becomes the yellow 1 for the G function. So what does the G say comes out? Looks like a 4 comes out. So that means we'd put a 4 right there. Okay? So let's do maybe one more. We'll do this one down here, the 4. So when I plug in 4, so I'm trying to do this box right here. When I do the 4, I'm dropping into G first, so I'm doing up here. So I've dropped a 4 in there. And according to this, I drop 4 into G and a 5 comes out, which means 5 becomes the input. So now I'm down here and I'm dropping into the F function. So according to this, when I drop a 5 into the F function, a 5 comes out. So that means this right here would be 5. And then likewise for this box, I'm going to drop a 4 in here. And according to this, I'm dropping 4 into F, so that means a 2 is going to come out. Then now 2 becomes the input, so I'm back up here now. 2 is the input. I'm dropping into the G function, and according to this, a 2 comes out. So I'd make this 2. Okay, hopefully that's helpful. I think this is a great question for once you understand what the table is telling you. It's a great question for really understanding this, the way composite function works. And I think getting this picture of 2, machines where you're dropping numbers in is a great way to understand functions. Because that's really what they are. You drop in a number, it does something to it, and it spits a different number out. And so just what happens is a composite function is really 2 functions in succession. One function is taking the output of the other function. So